So the next topic here is bending stress. In the previous video we have seen what is direct stress. Now we'll see what is bending stress. So the stress which is developed due to movement, the stress which is developed due to movement or bending, we can say, or bending is called bending stress. So the direct stress was produced due to the action of load, but bending stress is produced due to the action of movement. Okay, so we have force and we have movement. Force is producing the direct stress, movement is producing the bending stress. It is denoted by sigma b. Okay, sigma b. Now how to find out the bending stress sigma b? So for that we have to use flexure formula. Sometimes it is also called as bending equation. So this equation we have studied in mechanics of structure. So what is this bending equation? It is E by R is equal to M by I is equal to sigma B by Y. So to remember this, there is one formula also, or we can say one statement, that is Elizabeth Rani, may I follow you. Okay, so if you write this statement, the first letter will represent the equation. Okay, so now from this equation we will be taking this second part. So M by I is equal to sigma B by Y. From this, the value of sigma B is my by I. My by I. Now if you remember, there is one formula or one concept which is called as section modulus. So this section modulus Z is represented as moment of inertia divided by maximum distance from centroid or neutral axis. So if we write it in these terms, then we can also write sigma B is equal to M divided by I by Y. So this will be M divided by Z. So sigma B finally we can calculate by using the formula M divided by Z. Okay, now we'll try to see diagrammatically the same thing. So this is our vertical compressive member. This is the top view. And this is the centroid. We'll try to understand few important things here. So I'm taking the movement, it is acting in clockwise direction. So either it can be in clockwise or anti-clockwise. So here it is clockwise. Now if you look at this properly, you can see that this right hand portion or the side which is present on the right hand side of centroidal axis, this will be subjected to compression. Okay, this will be subjected to compression. So gradually if it is in compression, this will be in tension. Now what is the variation of this? The variation of bending stress is linear, and if this is a zero line, then there is one side which will be in compression and another side which will be in tension. So this right hand side we have seen that it is in compression, so we can draw it like this, and the left hand side is in tension. And the value here, this value is sigma b, and this is also sigma b. Only thing is that this value will be negative as it is opposite to the direction that we have assumed. We have assumed compression positive and tension negative. So now in the next class we will be combining these both things by doing the analysis of eccentric load.